Hi everyone, and welcome to Let's Stump Jen. Yeah, what a lovely day today, isn't? Yeah. Hi Neva, hi Sammy, hi Sam, hi Gary, hi Wally, and anyone else who's hanging around in the background and I can't tell that you're there or is going to hop in a little bit. Hi, welcome. Yes, I know the chat's been talking about the sad news about Sean Connery, and I only just found out a little bit before the chat said so because someone on Twitter sent me a message about it. And yeah, Gary's quite right. I'm a bit of a Sean Connery fan, not just because he's got that sexy Scottish voice, but because, you know, he was voted Time Magazine's Sexiest Man of the Year several times. So, I mean, come on. You know, I grew up in the 70s and 80s, so yeah, you know, he's quite a bit older than me. Well, was quite a bit older than me, but hey, he was still hot. So, but yeah, he's gone at the age of 90. We don't really have any more details on that. Just his family confirmed that he died. Let's hope it wasn't COVID or anything horrible, and he just went peacefully in his sleep. And yeah, condolences to his family and all the fans out there because. Yeah, we've lost another really good one this year. Fuck you, 2020. Yeah, he was 90, Sammy. So yeah, that's kind of derailed me just a little tiny bit. I did have some sciencey stuff to talk through. But yeah, I'm kind of like, yeah. And well, why don't we, talk about mortality and immortality, as it were, because I mean there is a crustacean, a crayfish that is effectively immortal. Genetically speaking, they can technically live forever. I mean, they don't because they get hunted by other animals and by us and eaten alive. But if you could keep one in a safe spot, environment and everything where, you know, where non-natural causes aren't going to kill it, like stupidly dangerous chemical levels in water and what have you, or predators or us or whatever. Well, technically we're predators. Not technically, we are fucking predators. Yeah, technically this crayfish can live forever. So that's a thing. Unfortunately, we're not exactly the same in that sense. Our telomeres, which are the end nodules on the, which are the end notes, the protective coating on the ends of our DNA strands, decay over time with reproduction, and we get to the point where we can no longer create replicas of our cells without defects in them. So, if nothing else, cancer will eventually get you. This is not the good type of mutation that makes our species get better and better. This is the crappy kind that ends up wiping us out. So, but there has been research into ways to make the telomeres reconstitute over time, and also to make them longer. So we end up with these extra padding strains that are longer on us, which will give us longer life. Well, not us particularly, but our ancestors' longer life, you know, our children's children or whatever, because, yeah, it's a thing that's going to have to, if we genetically engineer ourselves to live longer, it's not necessarily going to help any of us who are alive right now, but it may help those in the future to live longer, at least in a genetic sense, as in as an organic life. But something that might happen within the lifetime of some of us is what some people call the singularity, where we're able to transfer our consciousness into an artificial body. So you might be able to upload everything about who you are into an android that looks and acts like you, or however you want you to look, well, you'd act like you because it's your consciousness, but however you would want you to look, except you'd be an android. And in that sense, whilst not technically immortal, you are not going to die of natural causes as long as you can continue having your android body repaired and the brain of that android body isn't destroyed. Then technically you could live forever. So these are possibilities for us in the future of maybe living a little bit longer. Alright, I'll go back to the chat. So, hi Spooky, how are you? For Spooky's pregnant? What? No, yeah, and you're still just talking about Sean. Yes, I'm sad about Sean, but I am not going to let it destroy me. He was 90, he had a good run, we've got lots of really good movies, and as long as he didn't suffer, it was his time. And we all have a time, and I think we should celebrate the life that was rather than dwelling on the life gone, because the life is not completely gone. We remember him. His movies will stand for at least another 50 to 100 years, maybe longer. You know, he's not gone. There's a lot of information about him, but the him who was the vibrant life has moved on. Or gone back to the dust and dirt. So yeah, aside from being stumped about somebody who's died, which is often a thing, does anyone actually have any questions? Does anyone actually want to try and stump me? I mean, I know Sammy Jenkins always wants to stump me, but dude, we're in different states. You're not that big. What? Hey, Osman, did I get your text? Yes, you sent me a text, did you? Okay, okay, Osman, I will look for your text. What? Huh? Yeah. Oh, you sent me a text about Sean. Thanks, Ozzy. But yeah, the person who beat you all to letting me know was Godless Granny. She sent me a message on Twitter not long before the stream started, just to say, sorry, Jen, but one of your favorite actors died. So yeah. Everybody's like, gotta tell Jen that Sean Connery died. Yeah, he is one of my favorite actors, and I think his voice is sexy as hell. But it's not like this is a shock. Like, if he died in his 30s, I would probably be completely devastated by that. But you know, he was 90. But yeah, I am really a little upset about it, but not devastated. But yeah, you weren't the bearer of bad news, Osman. And it appears I was just the bearer of bad news to Sassy. I'm sorry, Mindy, I didn't mean to be. Yeah, Sean Connery died. His family announced it today. We haven't got any other details about what happened or anything, but yeah, goodbye to one of the best James Bonds there ever was. You know, I'm really hoping that I can persuade Wondering to do a media musings episode about Sean Connery, because I think that would be awesome, but that's not really what this stream is about, and I don't want to go into details. Yeah, he was a sexy man, Sassy. I did repost the tweet that the Godless Granny sent me. You know, if anyone's looking for the article that the BBC did about it, there are other articles, but yeah, they posted a news thing about it. So Not that I particularly like the BBC as a news source, but, you know, if you're talking about the UK, it's often the one to go for UK actors and things like that. So, yeah. Not absolutely wonderful, but definitely not absolutely wonderful. Like I said before, 2020, fuck you. So, yeah. Let's move on and actually do some science. Now that where we're at, yeah. Let's see. Yeah, okay, Sammy, you got a question? Go for it. Yeah, if the question's blank, I just have to sit here and look pretty because I don't have an answer for blank questions. Oh! You're talking about the continent that they think is part of the continental crust that New Zealand sits on. I assume that's what you're talking about. Now, for the life of me, I honestly can't remember what there's a few different things, but yeah, I'm not supposed to Google my answers, so, Mindy. I am supposed to be able to do this off the top of my head. The idea is you can try and stump me. Yeah. But yeah. It's... Oh, God. Damn you for Sammy. Start off with a good one. Yeah, I seriously don't remember. I know there was a couple of arguments about it. Oh, there's one under Southern Europe, is there? Yeah. See, the issue I have with declaring new continents is we don't have an incredibly solid definition of what a continent is. We talk about continental crust as in being the segments across that form the part of the mantle that forms the part of the crust that floats on the inner mantle. However, those crusts are constantly being destroyed and recreated. New bits are being added, other bits go away, and you can even have new bits of crust that can form later to form new continents. They're not set in stone. Well, I suppose they are set in stone because they're stone, but that's beside the point. It's more a case of defining the boundaries of what actually forms a continent is a lot more complicated than just saying, oh, that these particular places are continents. Well, no, we're starting to understand that the Earth's movements and stuff is the Earth's crust is actually even more dynamic than that, and over long periods of time can change significantly. So, whilst there are definitely parts of the mantle that are and the crust that are thicker in places than others, this is built up over time as well. So, while certain sections will probably always remain part of whatever is the continents in the future of the Earth, other bits will disappear and go away and reform. So defining the boundaries of continents can be quite difficult in that sense. So, yeah, there's often claims that there is a new continent in a given location because the crust is X amount thicker, or because this boundaried bit of crust moves separate from the other ones. But without a really firm definition of what defines a continent, it's actually really hard to say for sure what bits are actually continental crust and what bits are just other crust. So, yeah, it's one of those complex things where how many continents there are on the planet is variable over the course of time. And even even within the change of our own definition of what forms a continent. But yeah, I did not know that they were saying that there was a new one discovered under Asia. So it's a bit of both. Spooky. I mean, I know how plate tectonics work, but I also know that there's complicated issues as to how we define what a continent is, and the definition is loose enough at the moment where there are some things that people are calling continents now that we wouldn't have 20 or 30 years ago, and it probably comes down to geologists actually better defining what a continent is. And I think that will probably happen. I think, like many other things in science, we're going to have to redefine what our terms are, like we did with planets, and which it defined Pluto as no longer being a planet. My personal opinion, that a planet should be anything that has enough gravity to hydrostatically with its gravity form into something approaching a sphere, which means that all large moons should be considered planets, or planetoids at least, as well as all the planets themselves, etc. The only exception to that would be things that don't form a sphere, and things that have produced nuclear fusion, which would be stars. So that's my take on it. So yes, I think the larger moons in the solar system should be called planets, but that's just me. I don't think it's a requirement of a planet for it to... because all the moons actually orbit the sun. We talk about our moon orbiting the Earth, but actually what happens is the Earth and the moon orbit each other whilst they're both orbiting the sun. So the moon does orbit the sun. And it's the same with all the moons in the solar system. They all orbit the sun because it's a complex... Gravity is a complex dance, not this little clockwork system that they thought it was, back in the 1500s. Yeah, see, that's the point. Yes, Sammy, yes. At the moment, the definition of a planet is that it has to be orbiting the sun and cleared its path, etc. Or mostly cleared its path. I mean, it's actually impossible. A planet, even Jupiter, cannot clear its path because there are points, Lagrange points around its orbit where things can sit that Jupiter can never get rid of them. That they're in the safe point. That's a good question, Spooky. How many moons does the Earth currently have? Actual moons, 1. But you get the Earth intermittently has pseudo moons or quasi moons. It depends how you label them. That can fall into orbits that sort of look like they're going around the Earth, but really aren't. Are just being perturbed by the Earth as these objects go around the sun. And you also get ones that Earth captures, little asteroids that the Earth captures for a while and then releases. They're not. They do become satellites of the Earth, but they're not considered Earth's moon permanently. Yeah, one of them has a very good press officer. Well, that's true. Our big moon does do very well out of it, but it depends how you want to define the moon. As to how many pseudo moons we have at the moment, moons that are objects that are orbiting the Earth that won't continue to orbit the Earth. I think there is 1, but there may be 2. But yeah, most distant object visited by humans or our technology. Actual object, do you mean to land on it, Sammy, or do you mean just go past it? Because if you're talking about landing, the most distant thing we've landed on would be Titan. To go past, oh god, now I can't remember its name. But the Pluto Express probe that went out to photo Pluto went out beyond there and has flown past a Kuiper Belt object that we've got pictures of, and I cannot for the life of me remember what the name of that object is. That would be the furthest object that we've actually taken photos of and got scientific data for that is an actual object per se. But there is something else, the Heliopause, which is the point where our sun's our sun's particle pressure is no longer greater than the particle pressure coming in from the rest of the galaxy. So it's basically where the solar wind stops having an effect within our local area. We both Voyager probes have passed through that. If you're counting that as a thing to visit within the solar system, that's probably that is the furthest thing that we've actually visited and got data on, would be the Heliopause. So, what is spooky? Tighten your ears and chance. So, what did I get? Define. Why? Okay, I have no idea what you guys are now talking about in the chat, but I'm sure it's interesting to you guys. Yeah. So to go back to Spooky's question, I think there's currently one or two other pseudo-moons orbiting the Earth at the moment, which would make it 3 if you count them, but if you don't count them, we've only actually got the one moon. And the most distant objects would either be the Kuiper Belt object that Pluto Express has gone past and take photos of, which his name eludes me, I cannot for the life of me remember it, or the Heliopause. I'd probably go with the Heliopause just because it is a phenomenon of our solar system that's very important, because it's the effective non-gravitational influence. It's the limit of the non-gravitational influence that our sun has. So I mean gravitationally the influence of the sun goes much further, but it is very important because of that. So basically that was the crossing of the Voyager space probes into what would be considered interstellar space, which is quite fascinating, which means that's the furthest thing that we've looked at. But it depends how you want to do it. So thank you, Spooky. I like this blouse too. Okay, alright, does anyone else have any other questions, or shall I go into some science stuff that I've got up here? Oh, have I recovered from all the road trips? Never again. Yeah, I just got back from one today, so I'm doing a stream tonight, and I'm kind of tired, but I've missed doing this, so it's nice doing it. My road trips aren't over. I have put an offer in on a new house. It looks like this one will go through, so I'll end up with a new house. I'll end up shifting, actual proper shifting. Probably starting before Christmas, but I don't plan on hopping in we don't plan on doing the full on everything, moving truck move until the new year, because it's too hard before Christmas and the new year. It's not because I care about Christmas or New Year per se, but because getting most places shut, so it's almost impossible to get people to do things. So, and they also pump the prices up because it's the holiday season, so it's not something I particularly want to have to cop the extra expense, and I can wait to do the rest of the shift. Hi, Amber. But yeah. And I know if Raven's in there, she's going to be harassing me about when I should be using the word shift or move. It's the same thing. So yeah, I was going to bring up some data that has been released by NASA that the current research that has come about because of the Kepler and its its mission to look for extrasolar planets, or planets around other stars, shows that it's quite likely that there is a potential 300 million habitable planets within our galaxy, and some of those are probably going to fall within 30 light years of Earth, which is kind of interesting if you want to mess around with like the Drake equation to try and calculate how many alien civilizations are out there, because it gives us a better estimate for one of the things of the Drake equations. If you don't know what the Drake equation is, it's an equation given to us by Dr. Frank Drake in 1961, which was his idea for how to figure out how many civilizations like our own, or more advanced as well, could be in our galaxy. Basically, you use things like the average rate of star formation, the fraction of those stars that have planets, the average number of planets that can potentially support life, the fraction of those planets where life actually develops at some point, the fractions of life developed into intelligent life, and the fraction of civilizations that develop a technology that is detectable from other places, and the length of time that such civilizations are likely to exist. So what we have now is a better guess for the number of planets that there are in the galaxy, as well as the number of potentially habitable planets. Now, just because a planet's habitable doesn't mean that just because a planet's potentially habitable, I've lost train of thought again. Just because a planet's potentially habitable doesn't mean that it's going to have life or even develop life, because our problem is that whilst we know that for a planet to be habitable, it's got to have water and oxygen and carbon, and so we know what types of stars they have to form around so that they have these things. We've got some reasonable ideas, making assumptions based on our own planet, what to expect a habitable planet to have if it's going to be like ours anyway. But that doesn't mean it's going to have life, because we're not exactly sure what was the starting point for life. I mean, life may not have even started on our planet. It may have started out there in the greater universe. So these parts of the equations we don't really know. Then, of course, having life, as the equation says, you've also got to have intelligent life form for there to be a civilization. And people talk about the great filters. I think that is probably the biggest great filter that there is. Great filters are what is stopping us from actually seeing intelligent life nearby, because if there are numerous habitable planets within 30 light years of us, why aren't we hearing them? Because technically we should. Well, obviously there's some reason why that isn't, and I think evolution gives us the best answer to that, in that evolution doesn't tend towards intelligence. I mean, to a certain degree, you have to have some form of intelligence. You have to know that this thing is edible and that I want to hunt it, or I want to eat it off the ground, or whatever else. And but you don't need our, or even close to our levels of intelligence. Our planet did perfectly fine without us. In fact, arguably it did better without us. So, do you have to have intelligence develop on a planet? I think this is probably the biggest great filter that's out there, in that intelligence is not a requirement of evolution. Therefore, the number of intelligent species that evolved is probably going to be fairly low compared to the number of planets that actually have life. And even going from single cell life expanding out to multicellular organisms, in the probably 3 billion years we've had life on this planet, it's only been in the last 300 million that we've had multicellular life get onto the point where we're making complex animals. There's no need for it to do that either. Evolution doesn't even tend towards that. I mean, once it does, you get this spurt of development because it's a useful thing to have once you have it, but it's not a requirement. It doesn't aim in that direction. So yeah, there's a lot of things that can hold it back. But as to finding life out there, I think we'll find life within our solar system. Whether it's all the same life or not, it's going to be questionable until we actually find it. And I think we'll find that around other stars there's going to be life. But intelligent life is going to be rare. Rare and should be treasured. Like we should treasure ourselves and we should treasure our world. Because our world is kind of rare. Because we found an awful lot of planets and not an awful lot of Earths. So, yeah. That's the thing. Oh. Okay, what have I missed now? Do I get bed hair? Yes. Spooky, yes I do. Where are we on it? How many beans make 5 and why? Okay. We're gonna talk math, are we? Or is there some sort of joke in there that I've missed? Our numbering systems are purely arbitrary because they suit us. We have 10 fingers, so counting in decimals kind of makes sense. But there are other ways we could count. I have done in the past, like in groups of 64, which is kind of handy because there's a lot more fractions you can make for groups of 64s, and fractions are easier to deal with than complex decimal points. Decimals are great for high-level maths and engineering and stuff, but not so great when you're trying to trade with your neighbours, which is why a lot of other maths use different numbering systems earlier on. So, yeah, how many beans make 5? That depends on what base you're counting in. It depends on what language you're using to define your numbers. Lots of things. But for us, five beans is 5 lots. Defining a number with a number is complicated, but it's a tally of beans that adds up to what we represent as the number 5. So for us, that's like 1, 2, 3, 4, 5. So for us, it's 5. But depending on what your base is, how you count, what language you're in, could be something different. Why do we define our numbers that way? We just did. It comes through from the not just Arabic, but our number systems of Arabic, but also back to the Indian systems and and evolved over time. Our numbering systems evolved over time to be what they are now. So numbering is quite complicated, and number theory, yay! And what's with asking me questions that require me to use the question in the outside? That's really annoying, but spooky. So how many discrete parts in the smallest heap? Damn it, Spooky, will you stop this? I'm going to start ignoring Spooky. Will we ever discover intelligent life on Earth? No, I'm just visiting. What defines a life form anyway? Okay, I would say to have... it's really complicated because the want is to define something that can... organic type molecule that can split and reproduce itself. However, viruses are not considered life, and yet viruses kind of do that, but they also kind of don't, because viruses, to reproduce, have to borrow the mechanics of other cells, because they don't have it within themselves to reproduce. So they use another cell by capturing it and using its internal abilities to reproduce themselves. So they're a parasite. a virus is. So my definition of life would be an organic cell or form that can reproduce. Okay, what's my favorite biscuit? Monte Carlo. Why are you asking so many questions? The answer is 5, just because. Yeah, fine. I will accept that as an answer. Not the heat question, by the way. Hey, almost doctor. Our numbers are based on the numbers of angles in each shape. Yeah, that's another good way to define it. I actually... let's do this. And... that's fine. Yeah, sorry, I've sidetracked myself again because I'm good at that. Alright, yes, hi Matt, thanks almost the doctor for jumping in. Yeah, you stumped Jen with the car. Yeah, there's lots of reasons why our numbers are defined. The actual language of them is just as interesting as how we came about to define numbers, but numbers themselves. But yeah, our numbers are more a fraction system based from number lines. But you're quite correct. If we go back to the Greeks defined everything with how you could bisect lines or angles using a simple compass and a ruler. And the ruler didn't have measurements on them, so you were defining your measurements by the width of a compass, which is kind of fascinating when you consider that Pythagoras developed his theorem for the sum of the square of the hypotenuse equals the sum of the squares of the opposite two sides, of the other two sides, by using a straight edge and a compass. That's amazing. So yes, our numbers come from stuff like that. Yes, they do evolve. Where are we up to? PJ is here. Hi PJ! Hey lovely, hi in Davenport. Who else is there who I haven't said hi to? I apologise if I've missed anyone. What year did Crocodile Dundee came out? It came out in the 80s, and I cannot remember exactly when. I remember it coming out, and I saw it in the cinema, a little tiny cinema in Albany that was that particular cinema it wasn't around for terribly long. They call yeah, it was weird because it was the hall it was the cinema was built into used to be a clothes shop, and these people bought it, angled the floor, put cinema seatings in and a screen up, and it was cinema in the town for a really long time. Well, not a really long time, probably about 15 years. Prior to that, we didn't have a cinema in that town. We had drive-ins though, and I've seen lots of movies at drive-ins in my life. But yeah, that cinema went away, and they ended up building a cinema in the town hall. Before later on, I mean, it's got a proper cinemaplex in that in my birth town now, in Albany. But yeah, it's kind of fascinating. But yeah, I saw Crocodile Dundee in the cinema when it first came out, and I honestly can't remember what year it was. Sorry if I missed anyone's questions. Did you know scientists have identified 1004 main sequence stars similar to our sun that might contain Earth-like planets in their own habitable zones or within a 300 light years of Earth? Yeah. Here's the thing about sunlight stars. just because a star is the same brightness as our sun, or within that same category, I think. Now I'm going to be an idiot and get this wrong, but I think we're a G-type star, but I can't remember. Doesn't mean it is actually sunlight. And I'm going to use something that everyone who's into chemistry is going to hate. It depends on the metallicity of the star. So the content of materials that aren't hydrogen or helium, which astronomers call metals for some weird and whacked out reason, the content ratios of those elements would be consistent with the cloud that was around the sun that the planets formed from. So to have Earth-like planets, you would have to have a star that was similarly constructed. So similar amounts of carbon and oxygen, etc. So that you could have rocky planets that could have water and enough carbon for the life cycles, have nitrogen and everything. Stars that are poor in these heavier elements means that the planets that form around them are more likely to be gas giants and not have solid rocky cores and not be the size that you need to have an Earth-like planet. And just because a planet ends up Earth in size doesn't mean it's going to be in the Goldilocks zone that like Earth has, or have a moon that helps stabilize its rotation and its orbit. So or a big Jupiter that might be needed to protect these inner rocky planets. So saying that there might be that there might be 1001 main sequence stars similar to our sun that might contain Earth-like planets. Yeah, it's a way out there, us, because what we want is stars that formed similarly to ours, and that's going to be third generation stars that formed in nebula that had the right mix of materials to form planets similar to what Earth is. And that's an ask. That's one of the reasons why astronomers are looking for other stars that formed at the same time or in the same area as our own star, because they're going to have similar materials, so similar metallicities for the star and similar planets formed around them. They're the likely candidates to find planets like Earth. Just because we might find a rocky planet doesn't mean there's going to be enough of the other elements that we need, like nitrogen and water or oxygen for the water, etc. So we need to know that these other elements are present in these systems, because some of them are not going to have them. They're going to be forming in cloud forming regions that are weak in heavier elements, and that's an unfortunate thing. So those stars are less likely to have Earth-like planets around them. That's okay, Spooky. I don't mind hyper Spooky. They can see us. The thing about aliens seeing us, or us seeing aliens with technology, is that the further out from the sun, the further out you go, the more dilute the radio signals that we send out become, because as they spread out, they get wider apart, just like all waves do, and then they lose strength, and the signal degrades, and eventually you get to the point where the cosmic background radiation is enough that you can't distinguish the signal from the planet from that. Now, of course, you can do something to improve that by aiming a really, really powerful signal into one area of space with the intention that that signal will get to where you want it to go with less degradation, and hope that somebody out there has got a really nice powerful radio telescope to pick that signal up. That's one thing you can do. I won't go into more things, but the thing is, if there's aliens around us who even have radio, they're going to have to be within a couple of hundred light years, or we haven't got a hope in hell of detecting them anyway looking for radio signals, unless they've deliberately sent a message to us. And for that, they'd have to know we were here. So, yeah, it's a bit hard. What was the first film I saw in the cinema? The first film I remember seeing in the cinema was Star Wars. A New Hope. Oh, no, not you said cinema. Star Wars was the first movie I remember seeing at a drive-in. First movie I remember seeing in the cinema was Highlander, the original Highlander. I saw that. I also saw the I also saw Return of the Jedi in the cinema. That yeah. Now you got me clear. I don't remember what dates each of those movies came out. One of those will be my first in a cinema, and I can't remember which years they came out in. So, yeah. Okay, I don't know. No, I think actually Jedi's older than Highlander by a couple of years, so it might have been Jedi. That was the first one I saw in the cinema. Don't know. I was pretty young. Why can't I have sharks with fucking laser beams attached to their heads? Matt, you're the laser expert. You should know why you can't have sharks with laser beams attached to their heads. Well, you could have a shark with a laser. Yeah, I mean, you could get a little laser pointer that doesn't require much power, and you could glue it to a shark's head, and it would have a laser attached to its head, and you could probably make somebody blind with that. So you could do it. I don't know how long the laser... You'd have to have a waterproof laser for under the water, and the laser's not going to penetrate as far with the water because denser medium, and also... Yeah, it's... The laser's going to refract an awful lot in that water. But you could attach a laser to a shark's head. Now, if you're talking about lasers that could really, really hurt people, yeah, I don't think the shark would be able to carry around the power source needed to power the laser. You might be completely nobbling the shark there. Yeah, astronomers are crazy. Yep, I'm with you. You're doing a video on it soon. I want to kill with the shark. Can there be a planet that is flat? Oh, now there's a crazy ass question. All right. Would a planet naturally form that is flat? No. Because hydrostatics and gravity being what they are, once you get past a certain level of gravity, the planet's just going to start forming itself into a sphere. You know, gravity will take over and, well, form a spheroid, not necessarily a sphere, because your gravity is never 100% consistent because of the shifts in density around the object. Plus, you're dealing with rocks and hard shit that doesn't necessarily want to mold the way you want it to mold. So, yeah, no, a spheroid. Oblate spheroid. But yeah, ultimately you are going to end up with a sphere if you've got enough mass. However, a sufficiently advanced race could technically create a flat disk type world, which could still technically have gravity in it. Whether that would be worth doing compared to other things you could make as a sufficiently advanced technological society, I don't know, but it would technically be possible to have enough mass by concentrating the mass in a weird shape underneath the flat dome. I mean, ultimately it wouldn't be flat, but you could engineer it so it kind of looked flat, to give you a kind of gravity. Plus you could have the acceleration of the object if it's moving through space, give you have inertia, provide you with some more gravity, etc. So technically you could engineer a flat livable space that had gravity, well, pseudo-gravity, gravity via inertia. But I don't see that there'll be any point in it. large spinning space stations make more sense for creating an artificial gravity. There's lots of other ways you could do this. Of course, if we could make artificial gravity, if we had a quantum theory of gravity that let us manufacture gravity, no problems. You could build whatever damn shape you please. But naturally forming flat planets, no. Gravity sort of makes that an impossibility. If you tried to make something as large as a planet flat, the gravity itself would end up turning it back into a sphere. So, yeah, it's not going to happen. Yes, that's right. There is a solution to solutions to general relativity that can give you a donut-shaped planet. But I still think you'd have major problems with donut-shaped planets in that, still technically your center of gravity is still the middle point of all that. I think you'd find that with the spin that the planet would have and everything, that eventually it would collapse under its own weight anyway, and you'd end up with a spheroid. But you could technically have one for a while. Yeah, it is incredibly unstable. Yeah, it's always about gravity. Is taking a bath just people soup? You'd have to cook the person. I mean, I guess if you had a sauna that was... a spa that was incredibly hot, you might be starting to cook the person and you'd have soup. Or you might start getting flavour out of the person. But no, I don't think a bath is the same as soup. The bath's not warm enough to extract anything out of the person, apart from the dirt. I mean, if you want dirt soup, yeah, I guess. Maybe. Yeah, pretty much, Matt. It would be pretty useless, a donut world. Multiple people soup is more fun. Yeah, I could see multiple people soup being more fun. I'm glad you're in the chat there, Matt, to correct me. So yeah, well, let's pull up a another chunk of news. I just love the title of this because it gives people entirely the wrong thing. But this is an article about. I actually haven't read the paper, and I really want to. Maybe Matt has, which should be interesting. Scientists have photographed our galactic bulge. They really need to come up with a better term than that for it. Using a dark energy camera. The dark energy camera. Not a dark energy camera. Makes it look like we've developed these cameras just for wow. I mean, the idea of the dark energy camera was to help us learn more about dark energy, but it's not for photographing dark energy per se. It's for getting larger images, larger field of visions of stars, so we can get better map how the stars are moving, so we got a better idea of what dark energy and dark matter are doing. But that's beside the point. Yeah, so basically they've used this camera to photograph a section of the bulge of the Milky Way, which is like the center point of the Milky Way, because you've got the flat disk of the Milky Way and the center sort of bulges out above and below the disk, because there's way more stars in the center there. So yeah, so basically this camera takes 200 square degrees, an area which is approximately equivalent to 1,000 full moons at once, at a huge resolution. It's got 62 separate 4K CCD cameras, which totals 520 megapixels of data it captures at any one time. And basically they're just trying to figure out how the bulge formed. There are two competing theories at the moment. The one is that it formed very early in the formation of of our galaxy, so like in the first couple of billion years. And the other is that there's been a couple of generations of star forming activity that has made the bulge what it is. What this latest survey of the galactic bulge has shown that is most of the stars are actually quite old. So it looks like the majority of the bulge actually formed in the early part of our galaxy. So early on, about 10 billion years ago. So the bulge is actually quite old and is probably the main reason why our galaxy is built up to the size it sort of has, because you've got all this mass there. You become a dominant eating predator within galaxies when it's a bit like that. And of course we're heading towards the Andromeda Galaxy, which is another galaxy like our own that's nice and big and huge and eats other galaxies, and that's going to be one hell of a clash of the titans when that happens and the two galaxies merge and our two supermassive black holes at the center merge. There was some interesting things released about our measurements of the supermassive black hole in our galaxy Sagittarius A star, which shows that as far as supermassive black holes go, our supermassive black hole, not only is it not very active, it also doesn't spin very fast. And there seems to be a correlation with how fast a supermassive black hole spins as to how active they get. So we're quite lucky to live in a galaxy where we have a less active supermassive black hole, because the radiation that emanates out from an active galactic nuclei is so great that it can limit the areas of a galaxy where life could actually form, which would be devastating for us because we may never have been able to form. Now, we know our black hole has burped before, because we had the Fermi bubbles at either side of the galaxy, which is things from previous emissions from the black hole. But these are tiny in comparison to active galactic nuclei. So our black hole every now and then gets a little active and does do its thing, but it doesn't seem to be prolonged periods of time, and it appears that it doesn't affect the galaxy quite as much as some of these active galactic nuclei. So yeah, that's an interesting thing. Okay, a scientist is not good at names. No. Neither are YouTube wannabes. Who still eats people? Alright, speaking of cameras, what's with those aura cameras? Are they just heat detecting? Oh yes, the cameras that can supposedly detect auras. Yeah, now you're gonna bug me because I can't remember what they're called. It's most likely, they're a camera that uses a specific type of film to capture the so-called aura of the person. So it's most likely just that the camera's picking up other wavelengths of light coming off the person, because and then converting them into other colors for us to see. So like if you're using an and I just whacked my microphone, like if you're using an infrared camera so that you can see heat or whatever else. So it would be detecting other things that we don't normally see ourselves. Maybe it's possible that people who think they can see auras just have slightly larger ranges of vision and are picking up either things heading towards the ultraviolet or down to the infrared. But who knows? Another interesting thing about sight and how we see is that just because I see the color green and you see the color green doesn't mean we're seeing the same color, because color is interpreted in our brains. So whilst we have rods and cones in our eyes that are sensitive to certain frequencies of light, that's just sent back to our brains as electronic signals, and then our brain interprets that as the image that we see, and then applies colors. The colors are applied within our heads, and it's interpolated. So our eyes actually can't see the whole world, the whole image that our brain sees all at once, because we have this lovely little vision defect, because the nerve connections for our retina are actually in front of our retina. It's a good sign that evolution is a real thing, because seeing when you're a little fishy underwater, it probably didn't really matter all that much. But now that we're out here on land, our eyes are not good for land. Our eyes are developed in a weird way that no engineer would ever make an eye, because who's going to put it'd be like making a CCD camera element, and then instead of having the wires come off the back of it so you can use the full camera element, you run the wires off the front into the thing, so your wires are blocking your picture. So what our eyes have to do is move slightly all the time, so that our brains can build up a complete image of what's around us. So our eyes are always a little bit defective, and the image that we make is just our brain's interpretation of these images and putting things together. It's like the thing that we always see our nose, but our brain erases it from our view, which is kind of fascinating, really. But that's because the image that we see is just our brain's interpretation of what's around us. So there's no guarantee that the green that I see is the same as the green that anyone else sees. Just a nice little sidetrack there. Alright, where do we get to? Your favourite word is syzygy. What does it mean? What is my favourite word? Seriously, I can't remember what syzygy means. I'm not a linguist. My favourite word is probably cockwomble, and I blame Mero for bringing it back to my attention, but I love it. I just think it rolls off the tongue, and it's a great insult. So I love cockwomble. But they had some science behind them, or they wouldn't have been alike for sure. There's something to do with body heat. Yep. Be a hell of a party when the galaxies collide. Yeah. Well, the thing about colliding galaxies is we're reasonably sure that Andromeda's supermassive black hole is fairly quiet too, so it's probably a slower spinning one as well. But when the two black holes in the center of the galaxy start rotating around each other as they get closer to merge, they're going to speed each other up, which, plus with all the gas that's going to come in from these two galaxies pushing towards each other and getting in, because they actually basically scoop up all the gas in the surrounding area along with them and concentrate it into the new galaxy that's forming. Not only will we have a burst of star formation within our galaxy, it'll probably also make the new forming an Andromeda or Milkromeda galaxy that forms out of this merger into one with an active galactic nuclei, which won't be so great for any of our ancestors who might still be around, but it's a cool thing to think of. So yeah, it's interesting. Yes, I hit 600 subs a couple of weeks ago, Spooky, so I'm not sure when I'm going to be doing another party for it. I'm thinking I might do it when I hit 666, because it's the number of the beast. So that could be fun. Have a 666 party. How come people are not born with green hair? Oh, yeah, now that's an incredibly good question, and I don't know. We don't have chloroform in our hair. Well, I mean, our hair is made out of the same stuff, the keratin that's in our nails and everything. So I am guessing that there isn't a green form of that available, which is why we don't have green hair. I mean, even in the animal kingdom in general, you don't tend to get green hair. I realize there's exceptions to that, like sloths, but mostly animals that end up with green hair have it because of the things that live in their hair, not the hair itself. So I guess you could, if you wanted to have lichen grow in your hair, you could have green hair naturally. Or we have some sort of symbiotic thing where we have something that lives in our hair that gives us glow-in-the-dark phosphorescent hair and gives us the benefits from, a symbiotic thing that could do it. But yeah, I'm pretty sure that there's just a case that the keratin itself can't be green. Oh, okay. It's a good word, spooky, and it's not a word I usually use. I'm not actually an astronomer. I know a fair bit about physics, and I like astronomy, and I've done a bit of astronomy, but as in amateur astronomy. But it's it's a good word. Yeah, a colliding galaxy from our point of view would be quite boring because what is it? It's about 5 billion years until 4 to 5 billion years before they collide, and the collision itself will take probably another billion. Well, I mean, technically, the outer reach of the dark matter halos of Andromeda and the Milky Way are already colliding. So the outer reaches of them, and I mean, there's a huge distance between the Andromeda galaxy and the Milky Way. I can't remember it off the top of my head what the distance is. Not an astronomer. But yeah, the outer reaches we think are just starting to collide now. So yeah, so this collision in process between Andromeda and the Milky Way is going to take 6-7 billion years. I mean, in that time frame, our sun will probably no longer exist. So yeah, it's a really, really long time. So the boy with the green hair. Cool. I've never seen it, but that would be interesting. What's my favourite PJ moments, and how much do I love PJ's personality? I love you, PJ. You know I love you. You're absolutely fucking awesome. My favourite PJ moments? Oh... yeah, you're asking me to remember too many things, PJ. Yeah, I don't remember every discussion I have with people because I'm pretty dreadful at it. I've got a great brain for remembering facts, not names, but facts, and as to things that we actually have discussed, PJ, we have discussed so many things and talked so many times. But what do I love about you most, PJ, is that, you're one of those people who's always out there wanting to talk to people and be their friend, and you are one of the most supportive people I know in the community, which I think is just absolutely awesome. And you're somebody who's been through so much shit yourself, and you rarely ask for anything from the community, and yet we all love you and we're more than willing to give back to you at any time. So yeah, you are a gorgeous person, PJ. I love you. 1 billion years left. Yeah, is that right? Isn't the lifespan of a G-type star about 10 billion years, and our sun's nearly 5 billion years old? So it's middle-aged. But I mean, as far as before our sun, before the radiation levels given off by our sun are too great for life to maintain on Earth, yeah, we're probably talking about 1 billion years. So, yes, R.I.P. Sean Connery. I did mention that earlier in the stream. And hi, native atheist. Yeah, 7 to 8 billion years. Sorry. Yeah, it's yeah. With our current understanding of stellar evolution, and I hate using that term because when we talk about stellar evolution, we're not talking about evolution as in Darwin's theory of. We are talking about how stars evolve over time, because evolution isn't just a thing about organic systems. Lots of things evolve. Language evolves. Culture evolves. Stars evolve over time. They form in gas and dust clouds, and over their lifespan they will expand and they will increase in the temperatures they give off, and then they'll expand more and everything. So yeah, were I a punk back in the day? No, I wasn't, Spooky. To be perfectly honest, where I grew up, I don't think there were that many punks at all. So punk wasn't really a thing for us. So no, I wasn't really a punk. And hi, little wolf. So yeah, what else have I got here? Now this is something that Dave Critical Cripple reposted earlier. I think it was a couple of days ago, but about petrosaurs. So I've got to do something about dinosaurs at some point. Well, they're not that petrosaurs are dinosaurs, but related to dinosaurs, because I mean, petrosaurs and dinosaurs' common ancestor was quite a while back, before most of the dinosaurs that we're used to, well, I don't know why I quoted that, came into being. So, but so yeah, it's so the petrosaurs diverged from their dinosaur ancestors, the proto-dinosaurs, in the early Triassic, so around 245 million years ago. But our first fossils are dated like 25 million years later, so we didn't really see where they first started to fly, etc. So, but what we do know from the way that the fossils we do have of earlier petrosaurs and things is that early petrosaurs were not good flyers. They were actually quite dreadful at it. They honed their skills at flying over the millions of years, because, I mean, dating from our fossils date back from 210 million years ago to obviously to 65 million years ago when they became extinct along with the dinosaurs. So over that period of time, they hone their skills in flight till you ends up with like Quetzalcoatl and that one of the largest flying animals that ever existed, you know, until you get to the later petrosaurs, which were absolutely quite brilliant at flying. So flying as an evolutionary thing happened really, really slowly by degrees. When which is even against what a lot of people, what a lot of scientists thought, that a lot of paleontologists thought that the movement of petrosaurs into being able to fly was something that possibly happened quite quickly over, maybe over a couple of million years, but it looks like it actually took a really, really long time to actually get themselves up in the air and actually get good at flying. So the evolutionary timescale for learning to fly seems to actually be quite long for most of the species that have done it. I mean, aside from petrosaurs, we've got birds and bats as the other form. So we know that birds evolved from dinosaurs, but the time frame of evolving feathers to actually creating flight feathers to changing the arm structures to be structures more like wings and everything took a really, really long time for dinosaurs to evolve into birds. We know this. We know that gliding came first, as it probably did with bats as well. So yeah, it's the evolution of flight was a slow process that went in very small steps, which is great. Hi Dave, I was just talking about your post about petrosaurs. Pterosaurs. God damn it. It's late and I'm an idiot. Oh, and I've got some private messages. Let's see. Oh, no, nothing important. So yeah, I found that very interesting what you posted about pterosaurs. It was very, very. I found, yeah, it was fascinating that how long they actually took to evolve flight was yeah, was good and really in line with what we know of evolution taking time to get places. So yeah, I find that incredibly fascinating. Alright, so did I miss any question? Was I gothic back in high school? Yes, I was a goth for a while, PJ. I was a bit goth for a little while. And I was really good at writing morbidly depressive poetry. You're halfway through Spooky's DM, Dave. That must be a long DM. Or you're a very slow reader. Give you a poem. Alright, off the top of my head, I probably can't think of any of my poems that I wrote. I will have to dig up some of my old poetry books and that. But yeah, I might do a stream where I read some of my old poetry at some point, or just a video where I read through some poetry. I used to write a fair bit of stuff about death and usually vampires and stuff. I was heavily into playing D&D in high school, so yeah, death and horrible ways of people dying from being attacked by vampires or ilk or magic or whatever else. It was usually quite dark. Not everything was dark. I used to go with intellectual stuff. Like I wrote a poem, and if I could remember exactly how it went, about light bulbs, and yeah, it started out within the light bulb I have seen a little creature, short and lean. But I can't remember how the rest of it goes. What year were I born? I was born in 73. So yeah. You know how rarely I've ever played 3.5 there, nerdy? No, I couldn't tell you how many hit dice a vampire is in 3.5. I mostly played 2nd edition when I was in high school. I still own 2nd edition. I like 2nd edition. I have played 5th edition, obviously, and I've also played Pathfinder. But yeah, I really didn't play 3.5 all that often. Wasn't a huge fan of it. Yeah, I'm a nerd. Oh yeah, nerdy loves to stump me. I've been stumped a lot today. Born in the age of Aquarius. Yeah, I know that Pathfinder is close to 3.5, but like I said, I haven't really played D&D 3.5, and I honestly couldn't tell you what hit dice different monsters are. Not off the top of my head. As given that it's also been a really, I mean, aside from the few games that I've played online with Wondering, it's been a long while since I've properly sat down and played D&D, although I do intend on fixing that when I shift. Does infinity exist in mass? Okay. If you're asking, does a number infinity exist? No, it does not. If you're asking if there is things that approach infinity, well, yes, there are. All the time in maths. So effectively, are there infinities? Well, yeah, you can have collections of things that are effectively infinite or approach being infinite, are uncountable. For example, all the fractions between 0 and 1 are infinite. They have to be. Or maths doesn't work anymore. So, can you have infinities in maths? You can have the concept of infinity. You can have things that approach infinities. Is infinity an actual thing in and of itself? As a concept, yes. As an actual number, no. There are many infinities or things that approach infinity. Spooky, yes. And some infinities are bigger than others. But yeah. Now, if you're going to ask, are there infinities in the universe? It gets even more complicated. Can we have something that is infinitely small? Can we have... Can the universe go on forever and actually be infinite? These concepts are sort of a bit beyond our imagination. But yeah, according to quantum mechanics, we shouldn't be able to have anything smaller than a Planck length. So can we have something infinitely small? Probably not. But it would be damned hard trying to prove it. And yet, with general relativity, in theory, a black hole should be an infinitesimal, a tiny point of nothingness that's got almost unlimited gravity. I mean, we've got a singularity is an infinity. But does quantum mechanics preclude that kind of singularity, so therefore you no longer have an infinity? Because whilst we talk about an infinity within the singularity, that it only has a certain amount of mass. So it's a finite within an infinity. But we don't have a quantum understanding of gravity, so we don't really understand the answers to these questions. Having said that, there was an interesting article recently about the information paradox with black holes, where a group of physicists sat down to try and solve the problem with black holes and losing information. Because basically, once you get matter fall inside a black hole, you've lost that information. And quantum mechanics doesn't like things disappearing. It has major implications for how time works, and for supersymmetry and symmetry in general. So if we lose information in a black hole, it does cause problems for us in quantum mechanics. However, these guys use general relativity and some concepts from quantum mechanics as well, in a similar way to the way Stephen Hawking described Hawking radiation as a way for black holes to evaporate. And what they came down to is that at the densities of matter that you have in a black hole, and over the longer term lifespan of a black hole, the information and mass within a black hole will radiate away due to the gravitational effects of the black hole itself. So gravity over time with the black hole actually ends up being the thing that pulls the black hole apart slowly over a long period of time. So not only do you have the problems of Hawking radiation causing black holes to evaporate, black holes will actually eventually kind of not tear themselves apart, but sort of fizzle themselves out, and all the information within the black hole itself will escape back out into the universe. Of course, black holes are incredibly long-lived, and the universe is going to be a very dark and boring place when that happens, but it's not gone forever. Hi, Jeff. Something infinitely small. So you're saying that Nathan Thompson's brain is a singularity. Where did I get to? Some infinities mothers are bigger than other infinities mothers. That black hole firewall. With all the dust in the wind. Gravitational waves carry information. It is so confusing. Yes, I agree with you, Matt. I find it incredibly confusing. But, I mean, I know it's only a preliminary paper and it needs peer review and there needs to be a lot more study to it, but it is an interesting solution to the problem. The downside to it is, and quantum physicists are going to frickin' hate it, is that you don't need a quantum theory of gravity to solve some of these problems. And they're basically saying that just with some clever thinking about how quantum mechanics and general relativity works, we can solve all those problems anyway. Which, I mean, isn't necessarily a problem per se, but it does kind of squash our hopes of having a grand unified theorem, if that was the case. Nathan Thompson has no mass in his brain, so it's not a problem. Bye, little wolf. Is the law of attraction real? Well, you're talking about from a relationship standpoint, or are you talking about the opposite poles attract and like poles repel for magnets and charges? Oh, okay. So when will the current plague be over? Well, I mean, over is an odd way to look at it. I mean, flus that caused pandemics in the past have not just died out and disappeared. They're still around, but ultimately enough of the population gets it and survives it, and then pass on their immunities that they build up, that we become better at handling it, so those flus become less of a problem over time. So yes, assuming, and this is a big assumption because we have seen people recatch the current virus that's going around, and that could be a problem if we as humans cannot build up an immunity to it. Then no, this may not end until most of us are wiped out, which is a very, very sad thing to say, but it's possible. On the other side of that, I think it's probably more a case that, like with chickenpox or anything like that, where some people just don't build up an immunity, and those people are the ones who are unfortunate enough to get it the second time, whereas most people who have it would build up an immunity and they should be fine. It probably depends on how bad your dose was that you had, but you want a good enough dose that you get an immunity, but not a bad enough one that you die. And that's the hard bit. Now the other side of that is, of course, we're getting a lot better at making vaccines and things like that. If we develop a vaccine that is efficient enough for this, that even if you have to take a booster every couple of years for it, we effectively knock it out of rotation. If it's not getting into people, then it's not able to mutate as much, and then it's not as big a danger to us. The problem we have at the moment is it's so virulent, and we're getting so many cases, and that those cases are still getting passed on in a lot of areas, that the virus is having a fertile breeding ground where it's having a chance to evolve and get better, which is probably another reason why we're having people recatch it, because it's just getting better at getting around our immune systems. So we need to have our safeguards in place. People wear masks. Be careful where you go out and where you go to. If your state is not has a high occurrence of it, be careful. Do everything you can to protect yourself from getting it, or pass it on to anybody else if you happen to catch it. Because ideally, the only way we're going to beat it is to reduce its ability to mutate and become and avoid our immune systems, so that ultimately we can get a good vaccine that will give us the herd immunity that we need to be able to basically kill it off like we did polio. So yeah, well, we need to be vigilant basically. But will we get on top of it? Yeah, probably eventually, when we've got a vaccine, would be my guess. How long till we have a vaccine? There's ones being trialed now. How good are they going to be? Who knows? We normally take years to make vaccines, and we've had less than a year. So we'll just have to wait and see where we end up with this. Hopefully they'll be good enough to at least protect our doctors and nurses and people who have to work and people who are in the most danger. And then maybe at that point we can start getting on top of this. And if we could get political parties across the world having the will to put a stop to the spread of it, then yeah, that's even better. So go and vote, people. Make sure you vote for people who are actually going to make good public policy that protects people, and don't just throw caution to the wind and have as many people as they don't care about catch this thing. Okay. Wait, not time is relative. Okay. RNA viruses mutate quickly. Yes, they do, which is unfortunate. Current tech, but can I tell you how to make a coat? No, I'm not. I am not a biologist or a chemist, for that matter. But there are people who are smart, who are in these fields, who have been working on this thing for most of the year. I don't know. I personally think it's not been long enough. I don't think we're being sensible about how we're approaching this. I mean, yeah. I mean, look in my own state. Whilst there are 40 cases of COVID within Western Australia, there have been no active transmissions of the virus within the state for the last 3 months. All those cases are people who've come off ships or out of aeroplanes or whatever, who've come into the state and are now in quarantine. So, we more or less have it under control, and you're not having to wear a mask when you go out. You still have to socially distance and be careful and stay home if you're sick or whatever else. But we're more or less on top of it. If everywhere did the same thing, we could bring this thing under control. But people aren't, and that's the problem. So that's why we want a vaccine. And it's going to take time. Vaccines take time to make and test and everything. And my fear is that without proper testing, we could be creating a bigger problem than the problem we've got. Not that I'm anti-vax or anything, it's just that vaccines do need testing. People fucking up and making too many other people. Talk of a second UK lockdown, that wouldn't surprise me. I mean, this thing is going to constantly come in waves. The part of the problem is we get things start looking like they're getting better, and all of a sudden states go, well, areas go, well, let's open up, let's let people go back to pubs and back to doing these social things that of course we all want to do. The problem is the virus hasn't actually gone. It's still there in the community. And all we're doing by putting ourselves all close to each other again is spreading it again. And then you get more people sick again, and the curve goes up again. So we've got to have a balance there to get things under control. You caught PJ19, PJ. And now you've been sick ever since. Given that I've TARDIS here, I'm sure she'll be able to tell us who the first 3 Doctors were. Really? Okay, William Hartnell, Patrick Troughton, and John Pertwee. Unless, of course, you're going to count, what's his name, who did the movie version of Doctor who I guess was technically another version of the first Doctor, but given that I can't remember his name and I should be able to, it's going to frustrate me and somebody's going to yell at me from the chat. But yeah, I'm not going to count them. Of course, if you're going to go by the latest season of Doctor Who, there were Doctors before William Hartnell, technically. So we don't know who the first 3 Doctors were. In that sense. But chronologically, as far as when they appeared in the TV series, William Hartnell, Patrick Troughton, and John Pertwee. Okay, Trump lies like a child, yep. Biden lies like an old man, they all lie. Yeah, that's pretty true. Politicians can't help it. There ain't no cure for the PJ Blues. Aw, PJ, love ya. Can you tell us how to make a phone system based EMP? What are you wanting to do with that, Dave? All laser guns for personal use only. Yeah, see, I don't particularly like lasers as a weapon. They're really slow to burn through things. You're much better off with something like a plasma gun. You know, if you can superheat a little ball of plasma and fire it out, it's going to take a while for that ball of plasma, that plasma pellet, to cool down. And that plasma is going to do a lot more damage a lot quicker than a laser. So, plasma rifle? Yeah, I want a plasma rifle. I don't actually. I don't like weapons like that. But hey, plasma rifle would be kind of cool to see. Who asked better questions, Spooky or Dave? You both ask good questions. Night, Matt. Everyone should go sub to Matt. He is awesome. We'll go follow him, Not a Doctor, on Twitter. I did actually tweet out his details earlier. Almost a Doctor. Matt is the guy who was on the stream with Miro and I and Dr. Carl the other day. Matt's pretty cool. So yeah. Peter Cushing, thank you, Spooky. Hi, Batch. The timeless child needs to be erased. Yeah. I'm hopeful that they'll fix that. I don't mind so much the idea that the Doctor might not have been a Gallifreyan and the Gallifreyan's the way to regenerate off. Spoilers to anyone who hasn't seen it. Off another species. What I mind is the whole Master arc where he basically kills all the Time Lords after we just got them back. Fuck off with that. I hate you. Yeah, he was Grand Moff Tarkin in Star Wars Cushing. He was cool. Self-defense. Yeah, Peter Cushing was awesome. Almost, but not quite. Thanks, Dave, for putting Matt's details in there. Hammer horror movies digs through the DVDs. I hate all of it. Bye, bye. Oh, you're off, PJ. Bye, PJ. Love ya. Yeah. So I've been going for over an hour and a half now, and it's late, and I'm getting tired. But thank you guys for asking me questions. I hope I've been okay with answering them. Given that Matt's been in the chat and he's been able to correct me when I said a few things wrong, that's been awesome. I don't do these to necessarily share my knowledge because my knowledge is limited. I do this so you guys can challenge me because I like being challenged, because you stumping me or you throwing something new at me that I don't understand. Okay, I'll have to go back and find your question, Dave, or you have to ask it again. But you guys asking me questions helps me learn more. And I'm always up for learning more. I want to do some of these, and Matt's going to be one of the people I'm going to have on with me, where I do a Stump Jen and guest, where I have myself and I have guests, and you can throw questions at the guests as well as at me, because I think that'll be fun. They might be in at slightly different times, but I do like this time slot. I think it's a good time slot to have for doing them in, but I will try and probably do one that's during the week, so that's evening time for the US as well, which will probably suit Matt as well, which is good, and probably Mero and Mel, because I'm hoping that Scientist Mel will be involved as well with doing a few of these, because they're good fun and it's great to always have questions, and that those of us who want can try and answer, and I'll certainly have Dave on at some point. And Dave asked me a question: how do I, completely hypothetical, make a phone system based EMP for self-defense? So you want your mobile phone to have an EMP in it, basically. I'll answer the musical one in a little bit, Spooky. No, okay. Landlines. Alright, so basically you want to be able to send an EMP pulse through a landline phone. You want to spread it out over the phone system. I'm not sure you could now. Given, I mean, in Australia it'd be next to impossible to have a phone line based EMP system, because I mean, you might be able to take out an area, but you wouldn't be able to take out everyone, because because of the way the NBN's done, all phone systems within Australia have become voice over IP. So you're only got, in some areas it's all fiber, and the only cable is the cable in the house. So transmitting EM pulses through fiber optic would be impossible. So then you're going out. So in the area like where we've got fiber to the node in Australia, you've got copper in the ground around the area. I guess you could create an EM pulse that went through the copper lines and disseminated out through the other lines. I mean, you'd probably burn the copper out, the wiring out, before you actually could generate the pulse itself. But yeah, you kind of crippled from being able to do what you're talking about, because so much of the phone network now is fiber optic, and it wouldn't. But I guess you could have you could get an EM. Talking of EM machines, I always wanted to have an EM pulse machine mounted on the front of a car, so that if the car in front of you was pissing you off enough, you could shoot an EM pulse out, disable their vehicle, and just go around them. Because I reckon that would be kind of cool. Yeah, you could hook up. Yeah, you might have been able to hook up a generator in the past to it, but I think you'd be stopped from the usefulness of EM pulse over phone lines, Dave, by the fact that so much of it is fiber optic now. And we're talking voice over IP for so much of the voice communications that, the fiber optics would be a limiting factor. So you might be able to EM pulse a section of a network if it's still copper, but outside of that, no, I think you'd be stuffed. Going back to Spooky was asking me a question about musical instruments. Yes. And I do play musical instruments. There is a... must be over there. There are 2 electronic keyboards in this house. Neither of them are properly set up at the moment because I haven't set that up. When I shift, though, I will actually still be having a bit of a studio, which is kind of cool. Won't be the same sort of setup as I was going to originally have, but I should have room to set up some of my music stuff. So I should be able to have a keyboard set up, and I'll probably do some more music writing and stuff. But not only that, I'm also a brass player. I play trombone, I play trumpet, I have played in jazz bands and big bands, concert bands and orchestras. I played pit orchestra for a production of Jesus Christ Superstar. I have I've done quite a few different things. My favorite music for playing is jazz. I love jazz. I love jazz soloing and stuff like that. Maybe at some point, once I got my keyboard out and I'm doing some music, I might actually lay down a jazzy track where I actually play trombone solos over. I still have my trombone, so my embouchure is not very good because I haven't played it properly for a while, but that's mostly because I can't get to it at the moment. But yeah, it'd be something interesting to do. So yes, I play musical instruments and I love music. Okay, service depending on our landlines, you bugger. Yeah, everyone's attacking Dave because he wants to destroy landlines. Yeah, I went to band camp. Of course I did. Yeah, you realize it's a lot more innocent than you think it is. Finds it, he plays jazz. Yeah, I think I'll do some jazz. Did it with the instruments. I did not. I never did. Although I loved my music and did my music and everything, I wasn't particularly sexual in high school for obvious reasons. So, no. So yeah, I was going to wind this up at one point. So yeah, you guys sidetracked me. Mostly because I like to wind this up because I'm pretty sure Mel's on, not too far away, and I don't want to be on whilst Mel's on. So, who woke Ox up? Hi, Ox. Mel is on in 10 minutes, so yeah. So I think everyone should go over and say hi to Mel, and I should probably go and get some sleep. I might drop in the chat for a bit with Mel's stream, but yeah, people should go over and catch Mel. Question. Bonzox. Could you replace the horsehair in a violin bow with human hair? Why not? Horsehair used in violin strings tends to be a bit coarser than most human hair, but I guess there's no reason you couldn't use a big wad of human hair to play it. I don't know. I've never played a violin, so it's not something I know a lot about. Yeah, the human hair wouldn't last as long, but I don't see why you couldn't use it to play it. You could technically do it, but why? I mean, a lot of synthetic fibers are used now too for a lot of these things because they last longer as well. So yeah, I want to thank everybody for joining me, for asking awesome questions. To everyone in the chat who's been there for the whole time, some of you. For everyone who joined later, whatever, you are all fucking amazing, and I love you all so much. If you missed the beginning, go back. I think I spent the first 10 minutes eulogizing Sean Connery, and if people don't know, Sean Connery passed away today at the age of 90. Sad loss. But yeah, everyone who doesn't follow Mel should go over and catch Mel, because you got Mel will be covering a topic, and she does often answer questions from the chat as well. So if you want some more science feedback on stuff, go and have a good chat to Mel. She's way more smarter than me. But yeah, thank you all again. I will be doing some more of these in the future, hopefully with guests as well, so that it's not just me you're asking questions to, and so I've got somebody to banter with, because it's always fun having a bit more banter than just me talking, although I don't mind these just talking either. So yes, Ox, unfortunately Sean Connery died. So yeah, Dave's put the link to Mel's stream. Go and catch Mel, and again, thanks to everyone. I love you all. And don't forget to like and subscribe. Okay, bye.